All right, we're going to move into multiplying complex numbers now. You're going to do multiplying and dividing complex numbers in separate lessons. Multiplying should not be super difficult, but dividing is going to be more difficult because that is something you've probably never seen how to divide expressions before. But you've seen how to add and subtract like you did in the last lesson, and you're going to remind yourself in this lesson how to multiply expressions and then apply that to multiplying complex numbers. So first we're going to multiply just some polynomials. Remind yourself how to do that. So in this first example, when it says 3 times 2x, and it could also look like this, where the 3 is outside of our parentheses and the 2 is on the inside. Both of those are the same. Either way, you would multiply the coefficients. 3 times 2 is 6x. In example number 2, and similarly, it could look like this, or it could even look like this sometimes. So where the first one is outside and the second one is inside parentheses, or they're both in their own set of parentheses. In all three of those examples, you are going to multiply the coefficients. 5 times 4. 5 times 4 is 20. But you now have two variables that you're multiplying, and you learned in lesson 1.1 that there are these exponents here, that because you're multiplying, you are going to add those exponents to get y squared. So that is an important part that you need to remember, that when you are multiplying, you're going to add the exponents. In example number 3, you should be familiar with, you should know that you should distribute. You'll multiply when you distribute, so 2 times 3 is 6, and 2 times negative 7g would be negative 14g. In example number 4, similar to example number 3, you are going to distribute, but this time it's a 3n, so you're going to remember that there's a 1 for that exponent. So when you distribute it to the first term, and it also has a 1 on that first one, 3 times 2 is 6, and n times n is n squared, because 1 and 1 makes 2. And then 3n times 1 is 3n, because 1 and none makes 1. And optional, up to you if you want to put the 1 on there, n, or you don't have to, personal choice. In either case, that would be your answer. Those are not like terms, so you're not going to combine them. 6n squared plus 3n is your answer. All right, 5 and 6, you're maybe going to need a little bit more recall. In 5 and 6, you have seen these before, these types of problems, and you maybe have learned one of two ways to do this multiplication. Your first is FOIL. You've maybe heard of FOIL. And the second is the box method. I'm going to show you both so that if you don't remember at all, I'll show you both and you can pick one. Or maybe you're like, I kind of remember, but you don't remember which one you really remember. I'll show you both, and then hopefully one of them sparks a memory. But if not, after seeing the two examples, just pick which one you prefer. I don't care. Some people like FOIL better, some people like the box method better. It doesn't matter to me. You get the same answer. So let's start with FOIL. FOIL stands for first, outer, inner, last. So when you multiply, you are going to multiply the first term in the first parenthesis times the first term in the second parenthesis. That is the whole point of the first. And you're going to remember that both of those x's have a 1 for their exponent. So x times 2x is 2x squared, because 1 times 2 is 2, 1 and 1 is 2. O is the outer. You're going to take the outer terms now. The ones on the outside, you're going to multiply those. X times negative 3 is negative 3x. Then your I are your inner terms. So your inner terms, the two inside. 7 times 2x is 14x. And then L are your lasts, which is the last one in the first parenthesis times the last one in the second parenthesis. 7 times -3 is -21. When you do your FOIL method, you should be multiplying everything in the first parenthesis by everything in the second parenthesis. And then you will look for like terms because a lot of times there are, and in this case, it's the two middle terms, so 2x squared is the same. -3x plus 14 would be a positive 11x, and when you're adding, you do not change your exponents. That's not how adding like terms works. Just combine the coefficients. -3 plus 14 is 11, keep an x, and then minus 21. Okay. Now I'm going to show you the box method in case you remember that, or in case you don't remember this and you want to see if you remember the box method. You're going to make a box. My box is going to be a 2 by 2 because I have 2 terms by 2 terms. You're going to put the first parenthesis things on top of the first box. On your top. One term on top of the first little box, another term on top of the second little box. And then your second parenthesis is going to go on the side, the first term next to the first box, and the second term with its operation next to the second box. Now, to get inside each of these little boxes, you are going to multiply. So this box would come from these two terms. We're going to multiply those. 2x times x is 2x squared. To get this box, you go to the outside edges, which is the 7 times 2x, which is 14x. This box comes from the outside edges. -3 times x is -3x. And the last box, go to the outsides. -3 times 7 is -21. You have a 2x squared with no like terms, 2x squared. On your diagonals here, these two terms are like terms. 14x minus 3x is 11x. And -21 does not have any like terms. So in either case, whether you do FOIL or you do the box, you will get this answer. Like I said in the beginning of this example, I don't care which one you pick. Pick one that you like and do that one. In example number 6, you cannot distribute the exponent because of this addition symbol. If it was multiplication or division, then yes, you could apply the exponent to everything. You cannot do that with addition or subtraction. Because addition and subtraction inside there, this squared means to take whatever it is, this whole thing, and times it by itself. So it would look like this. And now it looks like example number 5. You are going to do your FOIL or box method. If you just distribute that squared to both of those terms, you're going to be missing one of your terms. That is not how a squared works when you have addition or subtraction. So I'm going to start with FOILing. 2r times 2r is 4r squared. 2r times 3 is 6r. So my firsts, my outers, now my inners, 3 times 2r is 6r. And my last 3 times 3 is 9. Combining like terms, 4r squared plus 6 and 6 is 12r plus 9. If you would have just distributed your exponent, which is incorrect, you would have been missing this middle term. So you cannot just distribute the squared when there's a plus or minus sign. Now, I am not going to show the box example in this example. If you did the box, make sure you get this, and if you don't, you should either ask a neighbor or ask Mrs. Mullen, and someone will help you find your mistake. Okay, let's talk about multiplying complex numbers now. It's the same rules and properties as multiplying your polynomials. Your number, I, is still treated like a variable, similar to how it was in adding and subtracting. When you added and subtracted like terms in the last lesson, you added your real parts and you added your complex parts. However, super important, when you do I times I, which is I squared, You learned in 3-1 that I squared is -1. So you're not going to leave it like back up here. You had it 4r squared. If this was a 4I squared, you wouldn't leave it like that. You would turn that r squared into a -1 and then do 4 times -1 and then go from there. So I'll show you some examples of what I'm talking about. And you need to remember, you want to keep end up your answer in a plus bi form. That means you should only at most ever have 2 terms. If you have 3, you are not done simplifying. If you have 1, that's fine. Maybe you didn't have that second term or whatever, that's okay. But you have to have no more than 2 terms. So 3 times 2i, similar to example number 1 above. 3 times 2 is 6i. 5i times 4i. 5 times 4 is 20. I times I is I squared. Okay, now this is where we got to keep going because we can't leave an I squared. I squared is -1, so this is 20 times -1, which is -20. Your final answer has to be in the form a plus bi. You are not allowed to have an I squared. So if you get an I squared is -1. You take 20, I squared is 20 times I squared. Since I squared is -1, it's 20 times -1, which is -20. Okay. Distributing on the next one. Distribute that 2 to both of those. 2 times 3 is 6. 2 times -7i is -14i. I have no like terms. I don't have any I squareds. I am in the form a plus bi. There is your answer to that one. Pretty simple. Distributing again in the next one, but this time we are distributing with an I. So 3i times 2i is 6i squared, and 3i times 1 is 3i. We are not in the form a plus bi because I have an I squared, which is not okay. I squared is -1, so that is 6 times -1 plus 3i. 6 times -1 is -6 plus 3i. Now I am in the form a plus bi. So anytime you have an I squared, you have to turn it to its -1, multiply the coefficient by that -1, simplify. And then make sure it's in the right order, a plus bi, which this one is. If it was backwards, make sure you flip it around. Example number 5 is once again one you have to do your box or your FOIL. I am going to do FOIL, mostly because I'm assuming most of you are going to do FOIL, but if that's not the case and you are doing box, you should still get the same answers. You also should, if you look back here at this example, when I did my FOIL in my box, I have all the same terms, 2x squared, -3x, 14x, and -21. Not necessarily in the same order initially, but you get the same 4 terms to then combine. So when you're doing your box method, you should have the same 4 terms that I have. If you don't end up with those, let me know so I can help you figure out your mistake. So FOIL first, 7 times 2i is 14i. 7 times -3 for your outers is -21. Inners, I times 2i is 2i squared. Right? I times I is I squared. And I times -3 is -3i. So if you did the box, you should have those 4 terms. Now I'm going to combine some like terms. I have a 14i and a -3i. So I have -21 plus 2i squared. 14 minus 3i is 11i. Now, I put it in this order. If you would have started with putting your 11i first, that's fine, but it's not going to be eventually because we do need to be an a plus bi. So I got my I at the end. But I do still have an I squared that I cannot keep. I have 3 terms. I can't have 3 terms. I can have at most 2. My I squared term is the issue. So -21 is fine. But I squared is really -1. So that's 2 times -1 plus 11i, which is -21 minus 2, right? 2 times -1 is -2 plus 11i. And now I have these 2 like terms that I combine, -23 plus 11i, and now I'm in the form a plus bi.
Good morning, it's Friday, it's picture day. If you
Squaring.
are ready to have your picture taken, you may come to the stage. Thank you.
Squaring means you multiply it by itself. So set it up your same exact but two sets of parentheses, and then do your box or FOIL. I'm going to do FOIL again, but if you do box, you should have the same 4 terms, and if you have an issue anywhere along the way, let me know and I can help you. First, 3 times 3 is 9. Outer 3 times 2i is 6i. Inner 2i times 3 is 6i. And last, 2i times 2i is 4i squared. Combining some like terms, the 6i plus 6i is 9 plus 12i plus 4i squared. But I still have 3 terms, which is a problem. The I squared is my issue. 9 plus 12i is fine, but this is really 4 times negative 1. That's 9 plus 12i minus 4. 4 times negative 1 is negative 4. And now I have 9 minus 4 to give me 5 plus 12i is my answer. Now, I did these in several steps, and there are some steps you could have done all at the same time. Same with back here. You could have combined your like terms and changed this to be a negative 1 all the same. It's fine. All right. It's fine if you skip some steps, if you combine some steps. I do just recommend skipping fewer steps. Combining them into one is fine. Like you could have combined, like I said, both of these in one step or something. But skipping steps, although possibly fine, does potentially take away some from some partial credit if you get something wrong, right? The more work you show me, the more partial credit you can get.